right, we're back. So, part 2 here of assignment 4.2. 18 is where I need to pick up from. So, let's talk about it. I'll write it down. See what happens. So, determine whether the following functions are monotonic from 0 to infinity. And so, to know if something's monotonic, you're going to take the derivative. And monotonic means it's only increasing or only decreasing. So if it's only increasing or only decreasing from 0 to infinity, we're going to call that monotonic. So for number 18, we're going to take the derivative. That's 2x and make it equal to 0. So their only critical number there when we solve it is 0. Let me show you my work. So take the derivative of x squared, make it equal to 0, solve it. So we're only looking from 0 to infinity. We're not looking anywhere else. So at 0 is a critical number. Now, if I plug in any number greater than 0, that answer will always be positive for the first derivative. So from 0 to infinity, this is monotonic. It's only increasing from 0 to infinity. Number 19. X to the 2/3. So what am I going to do with that one? Again, I'm going to take the derivative. So that's 2/3 times 1, and then subtract 1, or 2 take away 3, negative 1/3. Now, I'm going to write this as a fraction so I can just see it just a little bit better. So if I make this equal to 0, there is no answer. So the numerator has no variable. So it's impossible to solve for 0. But there is a value that makes it undefined. So what value makes it undefined? And the answer is 0. So there's one critical number, and that's when x equals 0. And it's critical because that's what makes it undefined. So it's either what makes it equal to 0 or what makes it undefined. So again, when I do a number line from 0 to infinity, for the first derivative, anything I plug into here, any positive number I plug into here, a positive number is going to stay positive. So again, this is monotonic from 0 to infinity. Number 20. Number 20, you'd think this one would be an example of maybe not, but we'll see. So we have 1/3 x cubed subtract x. Do you want to try it? Press pause, and then you can press play and just relax and watch that you did it correctly. All right. For those that did it, the derivative is 3 times 1/3 is 1. So it's just x squared, and the derivative of x is 1. So did you take the derivative correctly? Nothing makes this undefined, but if you make it equal to 0 and solve it, you take the square root. Now, normally the answer would be positive and negative 1, but we're just looking from 0 to infinity. So negative 1 won't be in my number line because it's only asking from 0 to infinity, but 1 will be on there. So I'm going to put positive 1 on there, and I'm going to see what happens when you substitute it into the derivative. So if you pick number between 0 and 1, like 1/2. Plug in 1/2 and square it, take away 1. That's going to be a negative answer. So 1/2 squared is a quarter, and a quarter take away 1, a negative. The big thing with number sense here is to know whether the answer is positive or negative, not coming up with the exact answer, and being able to do it quickly. And that is a skill, like any other skill. So I need you to keep practicing how efficient you can be to plug into the derivative and know whether the answer is positive or negative. Plug in any number bigger than 1, and that answer is going to be positive. This is not monotonic. So why is it not monotonic? Because this function decreases and then increases, creates actually a minimum, a turning point at 1. So if it's monotonic, there are no turning points. It either goes only up or it goes only down. All right, 21. I think these are now starting the review questions. And as I say, these are the most important questions, the review ones. because what you don't practice, you're definitely going to forget. For the problems 21 through 23, use that information. So you're given a position function of a ball. S at t equals negative 16t squared plus 64t plus 6. And time is between 0 and 4. It says don't use a calculator. And that position is in terms of height. So if I want to know the height at the beginning, plug in 0. You can see it's 6 feet to begin with. All right, so let's answer each one at a time here. So 21 says, on which interval of the time is the ball moving upward? So that would mean to take the derivative, make it equal to 0, and see where the derivative is positive. That's what we're looking for. So the derivative of this is going to be the velocity. So let's do that. I'll show my work here. So what is the velocity? What is the derivative of this? 2 times negative 16. Subtract 1 from the exponent. The derivative of 64t is just 64, and the derivative of 6 is 0. So there, I make it equal to 0, and now I'm going to solve to know when the velocity is 0, and then I'm going to create intervals and test them to see if they're positive or negative. So subtract 64, that's negative 64. Divide. So when you divide a negative divided by negative, you're going to get a positive answer. So what value for t makes the derivative equal to 0? What's the critical number? And the answer is 2. So this only goes from 0 to 4. So that's all I'm going to do. 0 to 4. And you can call it the derivative, or you can call it the velocity. So plug in a number between 0 and 2 into the velocity. So plug in positive 1, and you can see the answer is positive. Plug in a number between 2 and 4, like 3. And if I plug 3 in and think quickly, that answer is going to be negative. So the question is, when is this ball going upward? So a ball is being thrown upward, and then at what time does it stop and then come down? So for 21, we'll write a nice easy sentence. We'll say the ball is going up or upward from t equals 0 to t equals 2 seconds. Let's look at the next question. What is the maximum height of the ball? So to know the maximum height of the ball is going up, it rests, and then come down. So where the ball rests is the maximum height. Now, the time is not what I'm looking for. It's the position of that time. So if I come back here. All right, so if I come back here and recognize at 2 is when there is, and if I draw it, you can see there's a maximum at 2 seconds. Now, it's not asking at what time, but what the actual maximum height is. So I need to go back into the position function and plug 2 in to see what that answer is. So let's do that right now. So I'm going to plug 2 in, comes from here. So I know at 2 seconds it reaches its maximum height. What is that maximum height? Plug 2 into the position. So negative 16 times 4 is negative 64. 64 and 2 is 128, and 6. So I know this is 64 plus 6, that's 70. So what's the maximum height of the ball? And the answer is 70. And I think it's in feet, but I'll double check. Yes, okay. Number 23, I'm going to turn my page over. So number 23 asks for what time is the velocity increasing and at what time is the speed? And then it's nice that there's a little box above to explain what's the difference between the two. So when we're talking about increasing velocity, when velocity is increasing, another word for that is acceleration. And so when the acceleration is positive, the velocity is increasing. The difference between velocity and speed is that speed is the absolute value of velocity. So it changes the definition of it. So if I want to know when the speed is increasing, I have to look at both the velocity and the acceleration and see when the signs are the same. Either both are positive or both are negative, then the speed is increasing. But for increasing velocity, I'm only looking to see when the acceleration is positive. So let's go through each one one at a time. So first of all, I need to know the acceleration. So let's also make sure I write this down before I switch over. The velocity, which is negative 32t plus 64. Okay. Back here. And we already did velocity number line. I'm just writing it again instead of like just going back and forth with my page. So we knew that that's what I had on the other side from 0 to 4. And at 2, the ball stops and it falls down. So we know it rises and then falls. Okay, so acceleration here, take the derivative, and it's just negative 32. So the first question is, when is the velocity increasing? And the answer is the velocity never increases. So why does the velocity never increase? And the answer is because it's always negative. It's impossible to plug in a time when that acceleration is positive. So this is decelerating through all of it. So as you're throwing the ball, it decelerates all the way through. So the velocity never increases. Now the second part. The second part talked about the speed. So when does the speed increase? Is it the same answer? Well, it is always going to be negative from 0 to 4, the acceleration. And for speed, because it's the absolute value, we're looking to see when the signs are the same. So do you notice the signs are matching here? So in other words, the speed of it going in a downward direction is accelerating. So negative and negative. So after it reaches its peak, it's speeding up as it hits the ground. And this is telling me the direction and that it's going faster and faster as it's hitting the ground because the signs are matching. So the speed is increasing from 2 to 4. So from 2 to 4, the signs match. So for acceleration or for speed, speed is increasing when the signs match. Both could be negative or both could be positive. If it's talking about velocity increasing, then we're only looking to see when the acceleration is positive. And in this example, the acceleration is never positive. All right, 24. If the function, push this up a little bit, if the function f of x, and I'm going to write it down as I read it to you, x squared plus ax plus b has a relative minimum. So we know there's a relative minimum at 2, negative 4, solve for a and b. So let's see how we're going to handle that. So let's just start at the very beginning. A relative minimum means, if that's true, if you take the derivative, what would you have to make it equal to? Take the derivative, make it equal to 0, and then we can create a relative minimum out of that. But we need a second one. So if I take the derivative here, that's 2x. The derivative of ax is a, and the derivative of b, whatever the constant in, would be 0. Make this, because when the first derivative is equal to 0, it can create either a max or a min. So make it equal to 0. And we're going to solve for a. So the x coordinate is 2. So if I plug in the x coordinate, can you solve for a? So subtract 4, and you can see that a is equal to negative 4. So if a equals negative 4, it's going to create a minimum. Notice that this is a parabola where x squared is positive. So this is a parabola that folds up anyways. It is going to create a minimum there. So when a is equal to negative 4, it creates a minimum at 2 and negative 4. Well, we need one more thing. We need to know what b is, right? So for the next part, we can go back to the beginning and plug this point back here into the function. So f of x is a fancy way of saying the y coordinate. So the y-coordinate is -4. The x-coordinate is 2. We just found a, that's -4. X again is 2, and I'm solving for b. So you substitute in the values that you know, solve for what you don't know. So we're going to solve this. 2 squared is 4. Oops. -4 times 2 is -8, or subtract 8. We're going to combine like terms here. So 4 take away 8. And then when I add 4 to the other side, I get b equaling to 0. So what value for a and for b gives me that information? So I got a equaling -4 and b equaling 0. Let me just check my answer key to make sure I'm correct. So this is for number 24. A equaling -4, b equaling 0. Perfect. All right, 25. Oh, I gotta go back to this. Without using a calculator, find the absolute extrema of that function on that interval. So this is a review from the last lesson, from 4.1. So I'm going to write down the function. And the interval. So when they say the absolute extrema, they mean both. What is the maximum and what is the minimum value in that interval? So how do I do that? Well, ultimately I'm going to create a table of values. And on that table of values is going to be the end values of the interval. So -1 and 3 are going to be in that table. So I have to test the ends. Then I need to know the critical numbers from -1 to 3 and put those in. And then all I do is plug in and see which one gives me the greatest answer, which one gives me the least, and I have it. So how do I find the critical numbers again? We're going to take the derivative. That's 3 times 4, that's 12x squared. The derivative of -12x is -12. And the derivative of 1 is 0. Make that equal to 0. And then when I solve it, I'm going to add 12. I'm going to divide, so 12 divided by 12. Be careful, solving this, when you take the square root, will give me 2 answers, +1 and -1. Now, -1 is already here as one of the ends, so the one I need to add that's not there as a critical number is +1. So are you able to set up the table of values? Now, all you have to do is substitute in back into the function and see what the answers are. So for -1, I'm going to plug that in. I'm going to be patient, and I'm not going to give up on myself in my number sense. You can do this if you have to do this. So -1 cubed is -1. So this is -4. This is +12 plus 1. So 13 take away 4. That gives me the answer 9. I'm going to do the same thing for 3. 4 times 3 cubed minus 12 times 3 plus 1. This is testing the ends out first. So this is 3 cubed, which is 27. If 27 times 4, I can do that without a calculator. 28, that's 108. -12 and 36 is -12 and 3 is -36 and then plus 1. So ultimately I'm going 108, take away 35. That's 73. Then the last thing I need to do is 1. Now thankfully 1 is the easiest one to do. So if I plug in 1, I'm just looking at the coefficients. So that's going to be 4 take away 12 plus 1. That gives me -7. All right, so the question is the absolute extrema. So if I ask you for the absolute maximum value, I'm only looking for the y-coordinate. So the y-coordinate I get for the maximum of 73. And for the minimum, the least y value, I get -7. Can we check to see if I did that one right? So again, that's number 25. So we had 73 and -7. Perfect. All right, next one. We're almost done. 27. 27 says, find the critical numbers. Now, that's not absolute value. That is the greatest integer function. So, what are the critical numbers? Find all of them. A little bit of a trick question here. So, critical number means the derivative equaling to 0, or the derivative is undefined. So what x values either do this or do this. So do you remember what the graph looks like for greatest integer function? Let me show you. So for the greatest integer function, it's the greatest integer less than or equal to what you see. So it goes, and it does steps. I'm just going to sketch it. Remember those steps? And it goes all the way up forever. So if I asked you, where's the derivative equal to 0? You need an understanding that derivative means slope. That's one of the definitions. So if these are horizontal line segments, the slope of a horizontal line is 0. So every x value that gives you a slope of 0 is a critical number. That doesn't mean there has to be a maximum or minimum. Also, where is it undefined? Well, each x value where there's a jump, the derivative would be undefined. Now let's put that together. So if every x value where the slope is 0 and every x value where it's undefined, that would mean what? All x values are critical numbers by definition. Because by definition, where is the derivative 0? Where is it undefined? Every x value will either give you the derivative 0 or the derivative's undefined. So all x values are then critical numbers. Which doesn't mean you have a maximum or minimum or a turning point, because there are no turning points here. Just the definition of a critical number. I think there's 2 left. 28, 29. Can the mean value theorem, MVT, be used for this function? F at x equals x divided by x minus 2 on the interval from 0 to 3. Why or why not? And if not, find the c-value and so on. So let's look at it. So, can the mean value theorem be used for this? Now, there are 2 conditions. The first condition is that it must be continuous. Is there any x value here where there's a discontinuity? Any x coordinate that produces something that's undefined? Yes, look at the denominator. So when x equals what number? Is it not continuous? That's right. Is that number in my interval? So, does the mean value theorem apply? Why does it not apply? So, why does the mean value theorem not apply? Because in the interval, there's an x value that makes it not continuous, or there's a discontinuity. So, it must be continuous and it must be differentiable for this to work, the mean value theorem. So, it already failed the mean value theorem at the beginning, that it's not continuous. 1 left. Make sure that, I wonder how they explain it. There you go. All right, last one. Yay. 29. Find the c value guaranteed by the mean value theorem for that function. It says you may use a calculator. So already they're not even saying could or not. It's saying, I think it's going to happen. So if I look there, is it continuous and is it differentiable? And the answer is yes in terms of that. So that we can then go right there. So first of all, before I use my calculator, let me just write this. Let's write it down and understand the mean value theorem. All right, and I'm going to use my calculus calculator here. So you can follow along. You can also use decimals. But I'll show you with the calculus calculator how this works. So the mean value theorem means find the value when a rock equals I rock in that interval. So if it's continuous and differentiable, there's at least one value where they're going to match the average rate of change with the instantaneous rate of change. So how do I set that up then and then use my calculator? So a good step is to take the derivative, that's the IROC, that would be 3x squared minus 2x, subtract 2. Then I need to be able to set this up in terms of the slope formula to find the average rate of change or the difference quotient. So I have the derivative and I'm going to make it equal to the slope formula. So using these intervals, that would be f at 1 subtract f at negative 1, and then the denominator would be 1 subtract negative 1. And that's it. So I'm going to use my calculator to do the heavy lifting, and then we'll go from there. So to make this easier, I'm going to use my calculator. I'm going to press the toggle button here underneath the escape button in the top left. And in the graph, I'm going to press tab. I'm going to go back. I'm going to erase this that I have in there. And I'm just going to define the function, which is x cubed, move the cursor, subtract x squared, subtract 2x. Press enter. See, by defining the function, I can then press the toggle button again, and then when I go menu, algebra, solve, because it's already been defined in my calculator, it just makes it easier to type it in right away. So I have 3x squared, subtract 2x, subtract 2 equals, and then I'm going to do control divide to create a divide line. Then I can type in f1 parentheses, and I'm going to plug 1 in, subtract f1 parentheses, plug in negative 1, close it, and then in the denominator, I know 1 take away negative 1 is 2, but you could type in 1 take away negative 1, or just 2. Then to the right of the fraction there, I still need to go comma x. So underneath pi, like the bottom left corner, comma, then x, not the times, not multiplying, but x on the bottom. Control enter, and you can see the two answers that I come up with, which is negative 1/3 and positive 1. Now, are both in my interval? So 1 is close, so I'm thinking that 1 should be included. Negative 1/3 is definitely in my interval. So if they weren't in my interval, I'd have to cross that out. So the end point, I'm going to double check the answer key. If it's at the end, does it count? Or is it only negative 1/3? So let me just check the answer key. So I want you to notice in this answer key, when they solved it, you do get negative 1/3 and 1, but the only answer in the interval is negative 1/3, and then they have parentheses around negative 1 to 1. If I look at the question, did they have parentheses and I didn't see it? No, they had brackets. It's intriguing to me that the question had brackets, the answer key changed them to parentheses. Brackets means the ends are included, parentheses not. But with the mean value theorem, you're looking for a number in between the intervals. So I do think that the ends will never count. You're looking for a number in between, and the ends of the interval do not count in this case. So the only answer there was negative 1/3, or negative 0.333. Repeating is the only correct answer for that, for the mean value theorem. All right, you did it. So there's your assignment, completely done. I am super proud of you. Mr. G Math over and out, and until next time.